a lot of our intelligence is culturally transmitted. That it's something that's, it's cultural evolution. So it's a meme. In some sense, we've learned ways of reasoning. Again, there's some things for which that's not controversial. For example, the scientific method, to some extent, the formalization of the scientific method is something that we culturally learned.
Right. Absolutely.
We learned it's like, okay, we're going to make experiments, we're going to draw from experiments. And I think while we may have some intuitive notion of that, the systematic use of it is a cultural evolution. But I think if you go deeper, a lot of ways in which we reason is not necessarily something that emerges from our brain architecture, but rather something that exists in human culture that is transmitted through language or through teaching.
Hello, Arthur. Thank you for coming on The Augmented Life.
Thanks for having me.
You've written very provocatively about probabilistic programming, its connection with AI, and the nature of learning, both artificial and when it comes to learning as human beings. What first got you into that field?
Oh boy, it's a deep rabbit hole. And I know we're going to be talking about a blog post that I wrote. And I'm, obviously, I think to the extent that I have any type of public persona, people know me more about like the work I did in blockchain. But before that, or at some point during that, I spent a lot of time fascinated with Bayesian inference and probabilistic programming and how learning works, how AI can possibly work, and some of these deep questions. And the blog post you're referring to is a bit of a brain dump that corresponds to some of the insight that I gathered.
Right. And what particularly drew me to your writing here, I think, is a kind of, I thought, provocative thesis about how animal intelligence has evolved to learn abstract, but let's call it general reasoning skills, and how we transmit that to small children via language. And that doesn't seem to be the way that gradient descent works for artificial intelligence. So there's something missing, a kind of strategy that evolution found that has not yet made its way into the recurrent neural nets, the deep neural nets that we're building right now.
I agree. And I think the key is the evolution of what? And I don't think it's genetic evolution that is giving us. So I think genetic evolution clearly is giving us big brains that consume lots of energy. We have a lot of ways of being very, very clever about things, but in the same way that you might find a lot of animals being clever or like learning a lot of tasks or skills. But I feel like there's something different about the level of general intelligence that humans have. And one of the prediction that the blog post makes, which might end up being completely wrong, but at least it has the merit of making a prediction, is that a lot of our intelligence is culturally transmitted. That it's something that's, it's cultural evolution. So it's a meme. In some sense, we've learned ways of reasoning about things. Again, there's some things for which that's not controversial. For example, the scientific method, to some extent, formalization of the scientific method is something that we culturally learned.
Right. Absolutely.
We learned it's like, okay, we're going to make experiments, we're going to draw from experiments. And I think while we may have some intuitive notion of that, the systematic use of it is a cultural evolution. But I think if you go deeper, a lot of ways in which we reason about things is not necessarily something that emerges from our brain architecture, but rather something that exists in human culture that is transmitted through language or through teaching. And so the testable prediction is that if you have, as you sometimes have feral children or children raised by wolves, not literally wolves, but that's I would predict that they would be very, very clever. They would be able to figure things out that animals do not. Do this topic is it a short-term reinforcement learning that you might do something. You might get really, really good at hunting. You might get really, really good at doing a few things, but because you get this thing, but not necessarily long-term reasoning, abstract reasoning, long-term planning. I don't think there's things that you necessarily access via gradient descent of like this short reinforcement learning. I think the reason we plan is, yes, we have some examples of short-term plans, but the reason we make long-term plan is basically because we've been taught to make long-term plan, and the reason we can think about them is because we've been taught to think about things.
So there's like let's try to build this from the ground up first in the human case, and then explore how it applies to AI. So it just seems to be the case that teaching my children, watching how my children starting as babies learned that a very early step, maybe step one, is imitative, right? And I think it's easy to see that through this process of imitation, you can learn procedural knowledge, right? Like you see the walking happen, you try it over and over, and you kind of get this sequence down. That's purely imitative. It's not generalized in the sense that like learning to walk gives you some predictive model of gravity, right?
Right. And I think learning to walk is an example of this is actually an example of something that you can access via like reinforcement learning, or whatever it is that the brain is going to do, in a sense of you put one foot in front of the other and then you fall and then you learn that, if I put this like a slightly different ways, these are, and unsurprisingly, we are able to the area for learning train simple, you have this like models of humans with this fake muscle and all that. So you can learn this thing, and I believe a human can probably learn this thing. I also think there's probably a fair bit that's genetic about bipedal motion, right? So it's not something where you have to observe people, so it helps. But the nice thing about imitation learning is that it's much faster. You don't have to fail in order to learn to imitate. You can just copy the person, and then if you copy what someone else is doing, you can see fairly clearly whether or not you're copying successfully, you're not copying successfully. Or at least you're going to copy the superficial behavior. So you might end up doing cargo calls sometimes, but at least you're copying the superficial behavior. And then once you're doing that, you're basically building all the circuitry to later apply some policies to the map that you built to what's been there. And I think I think that's how we learn basically to reason abstractly. We don't start by reasoning abstractly and then say ooh, wow, now that I can think abstractly, it would be a good idea to learn from this person by copying what they're doing. I think by default we copy. And one of those things that we copy is basically this ability to think abstractly.
Right. So, I mean, broadly, I think that your falsifiable hypothesis is a kind of hypothesis about the limitations of gradient descent, which is almost a sport in and of itself. On Twitter and social media, where does this current set of breakthroughs driving models like LLMs kind of break down and prove to be a limit? There's got to be a way in which we can hypothesize about those limitations without lionizing good old-fashioned AI, which really placed this abstract core at the center of everything, trying to build abstract reasoning from the ground up, which also doesn't seem to be what babies do.
Yeah, but I think the abstract reasoning is interesting. One data point also that might confirm or infer what I'm saying, and I think you would lean towards actually being evidence against what I'm saying. So there's evidence for it. I think it makes a lot of sense. There's evidence against it. It's to the extent in which you have uncontacted tribes, for example, isolated tribes,
right?
And maybe they're not building rockets, but they are still certainly making long-term plans, right? About sex, maybe they're forging political alliances, they're doing all those things. So to the extent that you have that, you might say, well, that's not. There's a version of the story where it's just been transmitted from a long time ago, and that's just happened because they were not uncontacted at any point in time. They've come from other tribes that move into the area, all of that. But still, it's a long time, right? And so you could have a lot of cultural drift that happens, and those things will be culturally lost. So the extent to which they are able to do all this long-term planning and some levels of abstract reasoning is evidence for it. Evidence against it is if you have culturally significant difference in abstract reasoning, then that's evidence against what I'm saying.
Right. Okay. So tell me if this is fair. There's some, built-in learning capabilities that we seem to see in babies. It seems like it's strongly imitative, and those processes, let's say, were discovered by genetic evolution. Then you're saying that can't account for this later evolution of, let's call it, scientific reasoning. That evolution happened mimetically and is now being transmitted via language. Is that fair?
Yeah, that's completely fair. But I would say, like, scientific reasoning would be, like one of the most distilled form of that, and like one of the earliest form would be something more like, just abstract reasoning, making long term, like making some form of like long term plans. And by long term, I mean like few months horizon, so things.
And one of the things that I've seen you write about is the kind of reasoning that you bring to bear in black box reverse engineering. Like, you see inputs into some kind of black box. You're wondering, how does this black box work? You see outputs. And sometimes, if the box is simple enough, I guess you can just almost like brute force what the universe of possible mechanisms within the box. But usually brute forcing isn't going to work. You need to actually constrain your search with some reasoning about the processes within. Is that fair?
Yeah, that's completely fair. So, and to go back a little bit for where I come from, you have theories of intelligence that are basically based on this notion of program induction. So you're observing something around the world, and you assume there's some form. You have to have some assumption about the world, and so you assume there's some form of regularity to it, which is like Occam's razor. There's a simple explanation, and so the mathematical formalization of something like Occam's razor is to say, look, we have a simple, like, or rather, we have a complexity prior over the type of processes that may arise and like give rise to our observation. So that would be something like Kolmogorov complexity or Solomon induction. That's not tractable. Like, all of this looks basically like enumerating over an exponentially growing set of programs, simulating them. On top of that, you don't even know if they out. So this is not just intractable, it's also uncomputable. You have versions of it which are computable but still intractable. You can't really do that. And so the idea that we would be learning about the world by saying like, well, it's useful reasoning, abstract reasoning is useful to make sense of our senses, and therefore we will develop some form of abstract reasoning just to make sense of our senses. It's difficult. It's difficult to get there. I think you can get it for perception, but for action, it's really, really hard to justify. So one of the whenever you look at a reinforcement learning approach, one of the questions is like, okay, if you were to train some agent using this reinforcement learning approach, would they learn to save for retirement? It's 60 years from now. So they're not going to see many episodes of this. They're not going to be trained on many episodes of this, so that doesn't work. They can't take whatever short-term model they have of the future and like simulate a bunch of futures to decide to make this decision. Now, you have to take abstract leaps to do this. You have to make an abstract plan and reason about your abstract plan. You're not going to learn that through raw repetition in the same way that you will learn to ride a bicycle.
Right.
Which makes me think that there's a very strong cultural element to being able to. I could be wrong. So like, if I'm wrong, the way in which it would work is that somehow you manage to learn how to make very short-term plans. You understand how abstract reasoning is useful for making a short-term plan, and then all of a sudden you have this generalization leap where now I can make long-term plans, and it works. But looking at this program induction thing and the black box, the way where the rabbit hole I went into is one of probabilistic programming. And probabilistic programming essentially tries to do that. It's trying to say, I see a bunch of inputs, I'm trying to do Bayesian inference of it on it, but in the most general setting, I have a class of programs, and I'm trying to learn which program yielded the data. And the problem with all of probabilistic programming approaches is that they typically don't work. They typically don't work unless your program is leaking a lot of information about the computation it's doing. Right?
Mm-hmm. Yeah. Now, we formalize that when we talk about side channel analysis. But then it's hard to, I think that when we start modeling this kind of learning with probabilistic programming and then signal extraction and side channel analysis, it seems only applicable to programs, to artificial intelligence. Not as something that either was genetically or mimetically discovered and transmissible via humans. um, to a certain extent, I think what we're talking about is peering into processes. Like, I cannot teach you to be a chef by showing you pictures of ingredients and then pictures of final dishes. Like, I need to penetrate into like the processes and give you some intuition of how the processes interact with each other.
Yeah, and in theory, if I had a great model of physics, like perfect model of the world, I could say, well, I see the input, I see the output. I'm going to simulate every possible pass that has taken, and then based on that, I'm going to learn how to make the cake. Or I'm going to like combine the ingredients randomly and see like does that look more like the final product or less than the final product. Great, they're so weak in doing so. They're so weak. The thing about cybersecurity is interesting in side channel attacks because, again, like if you want to think about program induction, you can think of it this way. Imagine that your program is a decryption program, and maybe the decryption key is hard coded into the program. So doing induction on a program is equivalent to finding the decryption key. So that's as hard. Program induction is as hard as breaking cryptography, which means you probably can't do it. Um, and however, I am always fascinated by those papers and the analysis, but fascinated and scared. I say like, well, your cryptography is good, but if we have a telescope and then from a kilometer away, we look at the LED on your computer doing like power analysis, slightly blinking, then all of a sudden we can get your key. And the fact that even like a tiny amount of super, super noisy information, but that comes from the inside of the process makes the learning exponentially easier.
Right.
And I think that applies to I think that applies to Cuban, and that's why you show how to make the recipe. One of the things that I think is very special about language is that I think we think out loud to a large extent, and by thinking out loud, we are basically giving people a trace of our internal reasoning. You can see it as well, with like the O1 model, for example, of ChatGPT, and those reasoning models where they kind of have this like chain of thought, and they're talking to themselves into solving the problem. And that's how I think that's probably how they've been trained. On some opinions differ onto how it's been trained. I think there's a model called DeepSeek that might be open source that's coming up with something similar. So we'll see how they did it. I heard people say tree search. I heard people say like a lot of expert annotated traces, maybe a mix. But the common point is like you are looking at traces. Like that thing, you're peering inside the box. And I think the reason LLMs have been so successful, it's not because transformers, it's not because of the massive amount of data. It's specifically because they're looking at language, and language specifically is giving us a trace and an insight into human cognition.
Right. I do think that the evidence in support of your theory here comes from the surprising success of chain of thought. When specifically GPT-4 came out, I remember posing a tremendous number of tricky questions, both in the playground and via ChatGPT, that were trying to distinguish between a language model and a world model. Let me just ask you very tricky questions that are meant to reveal whether you have a really accurate model of how the world works. And broadly speaking, one-shot tricky questions failed. So it's a surprise when just getting the model to think out loud, which it's doing in language, yields better results. But it's not a surprise if this is exactly how language has evolved. Humans evolved language to be this information carrying signal for improving each other's world models.
Yeah, I think there's something to that.
Yeah, right.
It's not just communication. It's specifically sharing mental states and representation of the world. But I'm surprised when you try this because I know a lot of specifically like in against we're criticizing like language models for not having world models and so on and so forth. But my experimenting with GPT-3 when it came out, and I didn't have access to it, so I was experimenting using the AI Dojo.
Okay, yeah. Mm-hmm.
Sorry, not the AI Dojo. Sorry, the AI Dungeon.
That was a fun, yeah. It's still fun to play with. It's not like that's gone away, but yeah.
No, it is. But like at the time, you would go like, all right, forget about the adventure. Let me try you. Anyway, it wasn't perfect, but it had some world model. Like I remember a simple saying like, you're asking a professor what is a monotreme, and it answers like, well, it's a mammal that lays eggs. And then you're asking like a toddler what is a monotreme, and he blows a raspberry at you. So like there's some concept of like what's that at least shows some theory of mind. a little bit, or at least the ability to replicate what a theory of mind would give you. So it's not a great role model, but it had a role model. It understood, that if you actually, this is a complete parenthesis, but I like your strategy. You can ask people if you're standing on the moon and you're holding a pen and you let the pen go, what happens to the pen? Does it fall on the moon or does it stay in place?
Okay.
I wonder what GPT-3 would say or GPT-2 would say. A surprising number of people will tell you that the pig stays in place.
No. Oh, interesting. Okay. Right. So, I must say, I was intimidated for a long time by this idea that if you're truly intelligent and have truly mastered a topic, then you know how to explain it simply. And there's many things that I think I know very well and absolutely struggle to explain simply. And so I thought, God, maybe I'm taking myself too seriously, and I haven't mastered this material at all. But eventually, I evolved my thinking. I think that in order to be a good teacher, you have to not just have mastery of the subject matter, you also have to have an accurate model of the student's mind. So then you can model the gap that needs to be transmitted. Like the simple fact of the matter is, it would not have occurred to me that there would be a common misperception that people didn't know that the microgravity on the moon is sufficient for a pen to drop. Would not have occurred to me. So therefore would not have occurred to me to explain away that misconception,
Yeah, yeah. Well, the follow-up question is like, well, how did you think the astronauts stayed on the moon if there's no gravity?
Yes, right?
Well, they had lens.
Oh, that's so interesting. It's like there's folk bad causality, right? Like there's logic there, right? It's just it just overweights the wrong primitives.
But it's a cultural say because, they are hundreds of millions of extremely smart people who had the same folk model of gravity.
Right.
So, it's not that obvious unless you really, really saw deeply. But, it's so not obvious that the people who figure it out are hell as geniuses today.
Yeah, I see. Right.
So we shouldn't, it's a cultural thing. There's no one shouldn't feel smug about this because, people like, Newton and Galileo to figure this stuff out.
Oh, I hadn't really thought about the genetic evolution of language. So, of course, not all languages survive. So it's possible that you can consider a strength of language to be how powerfully and accurately it conveys between humans useful world models. So a large language model truly trained on language almost inherits the evolution of that language for the purpose of exchanging between human beings how like causality works.
Yeah, I mean, the thing is like there's a lot of confounders. So like, why is English so successful today? I think English is a great language. It's extremely composable, really easy to think about a lot of things. But like some of it is also due to the fact that the United States became a superpower and the British Empire was huge now. But did they become a super empire because they were using English? Which I mean, on some level, they were not so deeply impeded by their language.
Right.
There's so many other effects that are played, historical accidents and also network effects that will blow up in the need.
And the English language seems to have lower barriers than others to simply borrowing. So there might actually be some really interesting two-way causality there where peace, the Pax Americana, the emergent peace of the British Empire, is confounded by a language that has a massive working vocabulary by being open to adopting words from everywhere else.
I forgot the quote. I think the quote is that some languages borrow it in English rifles through the pocket of other languages for new vocabulary.
Yeah, I feel like that's pretty accurate.
So yeah, I mean, definitely, I don't think the British Empire would have been what it was if they were speaking Piranha.
Right. Interesting. Yeah. The kind of question that could be explored perhaps in the future with AI and vastly better simulation technology.
So the other thing to contend with is like, There are people, again, like okay, who claim to not have inner monologues.
Right.
So that doesn't necessarily contradict what we're saying as like language is a way to learn. Maybe you're learning through language, and then at the end of the day, you form non-linguistic representation inside your head. That would be my hypothesis. The other one would be that you have an inner monologue, you're just not privy to it.
Ah. Ah.
I could imagine that. But that should be testable. As like I think we should ask presenting question to people and see their language centers and who claim not to have. But you take people who claim not to have an inner monologue, people who have an inner monologue, you put them in an MRI, and then you ask them a bunch of reasoning questions or visual spatial questions, and you see like to which extent does one group have the language center activate versus the other.
Yeah, right. It seems to be the case that consciousness and the interconnectivity between different parts of the brain um, is critically timing based. An earlier guest on The Augmented Life is literally studying consciousness, not least by measuring brainwaves. And so I asked what brainwaves even are, and it looks as if it's a low dimensional signal that's like a projection from high dimensional space. So, this deep neural net that we all have between our ears probably has some natural dimension of, something high, 7-ish, maybe higher. Um, and and then the ways in which we measure brainwaves is just like a projection down to, lower dimensional space that we we read as a wave. And timing sensitivities can be seen, for instance, in schizophrenia. It seems schizophrenics, fascinatingly, often cannot be tickled in the same way that you cannot tickle yourself, which seems to be a timing dependent experience. So it's entirely possible that what differentiates the normal inner monologue from the schizophrenic inner monologue is not recognizing that the inner voice was you and thinking it is coming from God.
Right. Interesting.
Yeah. And that's essentially a timing error. So you expect your internal monologue to be in sync in some ways that have this consistent timing. If the timing's thrown off, it seems like it's a signal coming from without instead of from within.
The ticking part is because I always think the reason you can't tickle yourself is because you do to expect it or you recognize it as something that's coming from yourself.
Right,
So
right.
you have a synchronization.
Right.
But for schizophrenic not to be ticklish, it would be the opposite. They would have to like interpret it as coming from themselves or as being in sync with. That is surprising.
Yeah. So it could be the case that it's an erratic timing problem, right? It's basically an intermittent bug that's inconsistent, and therefore, like, you fail to adaptively learn in the right way.
That's interesting.
Yeah. When we were talking signal leakage, I remembered this sat solver enabled attack on RAM. It was called the cold boot
On what?
attack.
On RAM?
Yeah. It was a way of stealing secrets. For instance, a private key from its place in RAM. And here's how it worked: you could freeze the RAM, pull it out of a machine, put it into a new machine that is going to, like, literally make cold, like by holding a can of compressed air upside down. So imagine you freeze a RAM bank, you pull it out of that machine, you put it into a machine that's just going to dump RAM. Okay. Well, when you get the
That's why you don't want to use electrophyonics.
when you get the memory cold, you're basically preserving the bits even in the absence of power, right? So that you can do this read. However, some of it is going to degrade anyway. But the key thing is that ones are going to be ones. A 0 is going to be either a 0 or previously a 1 that has degraded, right? So that is enough of a constraint where you can take what you believe to be the key, right? You can trust all of the ones. You can half trust the zeros. Brute forcing a key is too hard, But if you have all of the ones and now you just need to brute force all of the possible combinations
Yeah,
of
well, only a few of the zeros used to be
that's
one.
right. So that problem can be, an SMT solver can do that, right?
Oh, right. You're not even brute forcing. You're also cutting down on your space by
You're dramatically cutting down on the space. So then even if you're sort of dumb from there, it's there's only going to be possibly one valid solution. You can test, across every possible permutation and then select the one it's just a constraint satisfaction problem, right?
So the ACT, yeah, sorry, go ahead.
Yeah. No. So similarly, it seems to be the case that in order for our brains to be power efficient, right, we have to we have to constrain our search space as we're trying to figure out how to do good cooking, say, and that involves peering into the black box, developing some like basket of heuristics around what could be good processes within that box.
Right. So that actually reminds me of that's one point I made in the blog post. It's one of my favorite example, and it's a way to demonstrate the importance of abstract reasoning. It's like, why do you do abstractions? And this is a very clear mathematical way of like showing in a very clear example. So it's a pigeonhole principle. So the pigeonhole principle states that if you have 100 holes and 101 pigeons, and you want to put the 101 pigeons in 100 holes, then at least one hole is going to have at least two pigeons. There's no other way to do it and that seems fairly obvious, right? But we might want to prove it. And how you prove it is going to depend on your system of axioms. Now, the statement that I made about 100 pigeons and 101 holes, I could write it as a Boolean SAT problem.
Sure.
Or I could write it as a first-order logic problem. And if I do that, then the proof is exponential. So proving that it's true is exponential, even though the proof might seem very simple. If you want a known, you need a stronger set of axioms. You need like a stronger type of logic if you want to be able to prove that very quickly. And what you need is integer. If you have a series of integers, then we can prove it immediately for all integers. And because you can prove it for all integers, you can prove it in particular for one integer. So even though you are making a statement about a finite number of pigeons in a finite number of holes, if you don't want to have an exponentially long proof, if you want to have a concise proof, you first need to recast your problem in this imaginary universe where infinite numbers exist.
Right.
Write your proof and then come back down to this finite world. And so you're making you still like making statement of a finite objects, but now you have a very different type of proof, and your proof is much shorter now because it's a fairly trivial theorem. And the way I think it applies to reasoning, and it's applied to probabilistic programming in the same way. So if you have a problem and you're just trying to sample your way out of the problem, say I'm going to try many possibilities, and some possibilities will look slightly better than others. I'm going to try to combine the ingredients of the cake, and then maybe the cake will look a little better in a certain way, and I'm just going to try to get there. You're never going to get out of it. You are hitting an exponential complexity wall. You need to be reasoning about your ingredients, and you need to be forming theories. And I think sometimes when people talk about artificial general intelligence, there's this question of is there such a thing as general intelligence? Do we just have a bunch of recipes? Or is it just a bunch of things that we've learned to do and that we're good at? And then, maybe this has been color translated, but to the extent that there is something that would define it, that would characterize it, I would say it's this ability to basically form theories and inform theories about theories, inform theories about theories, and make this proof. So build this abstract and conceptual ladder and use those to make conclusion about practical cases.
Yeah. All right. So bear with me as I try to go back to my cooking metaphor. What we're trying to distinguish is between cooking from outputs versus learning to cook from outputs versus learning to cook from procedural traces. And your example of really a new form of metasystematicity, this understanding of integers, is a kind of procedure that helps you learn a fact about the world, helps you learn the pigeonhole principle that otherwise is extremely difficult to prove.
So another example is the success of SMT solvers. So SMT solvers have been useful for program proofs. And for a while, people will say, like, I'm going to take my program proof, I'm going to turn it into a SAT problem, and then I will use a SAT solver and it will solve it. And I think mathematicians and programmers love to do this because you have a complicated problem, you reduce it to a problem you know how to solve, and then you use your general solver for the same. But
exactly.
when you're doing this, you're dropping a lot of information. You're dropping the fact that these things are integers and that you will actually have a whole theory of integers and reason much more effectively. You understand, you're dropping all the symmetries in the problem. You're dropping all of this like abstract knowledge. So in theory, your SAT solver, if it were very, very good, would be able to not just solve SAT, but say, oh, wait a second, I'm not just solving any problem. There's structure there. Let me extract the structure. Let me make a theory about this like larger, more abstract objects, and then I'll come back down to give you your answer.
Yeah.
It's obviously easier if you just keep the structure, and that's why I think like solvers like Z3 and others have been extremely successful because they keep more semanticity in the problem.
Yes. Okay, I've got my cooking metaphor. You can it is obvious that some things taste better when you char them, barbecue for instance, and you could literally brute force char everything. The actual causal theory of deliciousness is that it's the Maillard reaction that is the thing that actually produces deliciousness. The inputs of the Maillard reaction are very specific. It's not just about heat. You also need fat and at least a small amount of sugar or some kind of starch that will break down into sugar. If you lack one of those three things, what you have is carbon, not deliciousness. So understanding the specifics about that process.
Right.
Sorry?
The Maillard reaction is not just caramelized. It's when it happens to protein.
Yes, exactly. I silly me. I mentioned the fats and not the protein.
So it's when you make like a very nice brown steak.
Yeah, exactly. Yeah.
Well, I don't know. Like when you make creme brulee, is it also a Maillard reaction with some protein in Charlie, or is it not? It's just pure caramel.
I think so. Yeah. Yeah. So the you're caramelizing the sugar, but there's something about the fat load that makes it different.
Yeah, but caramel is also not typical. Like sure, typical caramel will have some milk that's pretty.
Caramel has exactly cream. Yeah.
Yeah. But it's not. I don't think it's a fat. I think it's the protein in the milk.
Right.
We're straying. But yeah, no, in terms of like the other funny example that I give that I like is the fact that a common teaching tool is a pointer.
Yes.
Like you're literally showing the trace of what it is. Yeah, you are literally showing the trace of what it is you're doing. But I think if it comes down to a theory, like if you wanted, if instead of just saying like let's sit down and say like, yes, clearly this shows that AI was would be possible by learning from traces and from languages. We already know that. So now we know that. But if we want to derive some practical insight for it, I think in terms of teaching, it's really this idea of teaching. It's a step-by-step approach. It's like basically like dumping all mental states, dumping all mental traces, then demonstrating, pointing at items, like really following the algorithm. Because learning to follow an algorithm is much easier than you just learning like the next step function is a lot easier than the whole function.
Yeah, exactly. Yeah. So a lot of our human peer-to-peer teaching is about exposing the trace from end to end, and usually sometimes, of course, we communicate that visually or by example when it's procedural knowledge, but we're also talking it through in order to try to, it's almost like provide the debug output for the thing that's being studied or taught.
I wonder if you could do side channel attacks on someone, or you ask them a question and you see how much their brain heats when you ask
Well, I guess Tversky and Kahneman found a side channel of pupil size for studying people when they're working memory. So yeah, why not heat? Or actually in that analytical frame, that's exactly what brainwaves are. It's a kind of side channel leakage.
or EEG in general. Like, you can
Yeah, right. Yeah.
Yeah, the funny thing is like, so I'm not an expert, I'm not a neurologist, I don't conduct studies with MRI and anything like that. But from all I read, it seems like we might have really good correlates of lights. We might have working light detectors now.
Oh, right.
It's just
Yeah.
like extremely expensive and extremely cumbersome, and you can't really really. I don't. The thing is, like, I don't think it's been tried against adversarial. I don't know how adversarial the trials have been. In terms of
Right.
like, tell me what the color of the sky is. It's green, and you can see that it's fake. But like, trying. I don't know if they've tried it with people who are really trying to hide the truth.
Well, I'm not sure that there's actually an empirical count of what is the functional difference between answering truthfully and answering with a lie. Like there are multiple forms of untruth. So it might be actually too hard to write the functional spec of what lying is, even if you had perfect instrumentation of the brain's processes. Can you identify which processes are like causal for lying?
And you could be saying, I think the thing that would define it the most pragmatically is the intent to deceive.
Right. Okay. Yeah. So is there a side channel for intent? That's interesting. Maybe.
Then you could be, I could be saying a true thing, but I'm omitting parts of the truth, and so I'm trying to change your mental frame by like selectively saying certain things and not saying other things. Um, Whereas if I'm genuinely convinced that I did something and I say it, it's not really a lie. It's not really a lie.
It's just occurring to me, speaking about intent, I'm connecting with what we were speaking about earlier about how we teach human children versus AI. Um, Not only are we exposing our own, let's say, stack traces with all of the explanatory words when we're trying to teach children, but they have an impulse to get you to expose the stack trace by recursively asking why, right? Like we've all seen that with children. They really want to ask the why question a lot.
So I've seen several theories as to the why, and there's a cynical theory and a non-cynical theory. The non-cynical theory is what you said. They want to expand on the trace, they want to zoom in on something, they want to learn more. The cynical theory is like they figure out that if they keep asking why, they get more attention, and attention is good.
Good point. Okay, it's entirely pro survival. Yeah.
And the cynicism of this is like children asking for attention is adaptive because it gives them more exposure to traces, and so one is not necessarily go against the other.
Right. Oh, but there might end up being some like group selection for cultural norms of indulging why questions. That's long-term pro survival for the entire group if you have that as a cultural norm.
Yeah, in general, I would bet that all of people gets tired after the 50th why.
Right.
It takes a lot of commitment. Also, like a lot of questions like simply don't have a good a lot of topics simply don't have a good why.
Right.
The ACO's thing, which is like the purpose of science is explaining how and why.
Yes. Yeah. Good point.
But try to reframe that.
Yeah. Interesting.
I think at the end of the day, why is also like it's an animist question, right? It's like
It is.
has in the same way that evolution doesn't have a purpose. It's just a process, right? But it's very easy to imagine that it has a purpose. And if you imagine it as like agentic and having a purpose, it's a lot of the time it's not a bad shortcut to think about it. So you can think of a lot of things that are agentic, which are not really agentic. And
Absolutely.
if you are a human and everything around you seems agentic, like that's the animist view. So you're going to ask why, because maybe you're asking about there's the idea that everything is like teleological. Teleological.
Exactly. The specifically the way this could have arisen via evolution is that this entire metacognition process of black box reverse engineering could have began as a social process. So it was entirely about humans trying to understand other humans. And because that's the locus, then it gets applied to the rest of the external world precisely because of the animist intuition. So you find that other people are predictable. Like you literally end up building a model that is predictive of the behavior of these other people, and then you can apply that to whatever, to animals, to an entire natural ecosystem, and that eventually becomes abstract scientific investigation. But it actually begins in this animist way.
So I think that's also part of the why.
So how do you think we shortcut this and improve on the training of artificial intelligence systems without having to teach them animism?
I'm not sure we should improve too much on the trading. I'm quite concerned with the pace of progress and like, or not so much the pace of progress, the differential between the pace of progress on capabilities and the pace of progress on alignments. If alignment we're going 100 times faster and pace of progress we're going 10 times faster, capabilities would be a big win. So it's not about the speed; it's about the differential. So I'm not sure we should, but to a large extent, well, what we're saying here like confirms a lot of the approaches which are taken. So I don't know that it changes anything. That deeply. Also, I will say that I think the blog post is from 2016. So at least I'll claim a few like internet points out of having written this as for lack of anything else. Um, there's ways you could prove it wrong. I think if you were to like set up a bunch of cameras and just learning purely from video feeds with no language whatsoever, and then somehow you had a thing that was capable of doing like some notion of long-term planning, some notion of like abstract reasoning. And I guess all what I'm saying is wrong in the sense of like it's not literally transmitted. You can actually like just learning from the data was really indecent. One observation that I think was sharp overall, and it was in the it's discussed in like, there's a recent Warren podcast which Rakesh where he talks about that, which is we still don't have a good way of training AIs to do planning. And the reason that today you can have a PhD research letter conversation with GPT-4, but not hire it, is because agents are kind of crappy. But it's a miracle that they work at all. And sometimes the thing that they work because not because it's ever been trained to do anything agentic. They work because it's read enough texts describing what planning looks like that it has this notion of planning. And my belief is that humans are not much better planners in this respect. Like maybe a little, but fundamentally, we don't learn planning by reinforcement learning. Um, and so I would say it suggests a lot of like approaches with potentially synthetic data, where you create a lot of synthetic data sets related to planning, where you have the solvers, you have the stats, so you could like, use a bunch of solvers to solve software attacks, show some traces, and then learn from those traces.
It'd be interesting to see how to reward that. It's actually, to your point, it's hard to teach human beings planning. So it's actually hard to label the outputs as like good or bad. But we get onto the barrier, we run into the barrier of our own limits of judgment when trying to transmit planning as a skill.
Yeah, but the thing is like we confabulate, right? And so coming up with you could come up in a plan through non-clever ways, like you could come up with a plan through brute force. And after that, try to backwards justify this plan from some, like annotated from some high-level reasoning, and then try to learn directly to have performed the high-level reasoning that will give you to the plan. And a lot of this thing happens in math as well. Like there's two ways you can teach math, and one of the things that I always find. So you have the historical approach. If you want to teach complex numbers to someone, do you follow the historical approach and say, well, you have the cubic equation, and you're trying to solve the cubic equation by radicals, and it turns out if you can't really express it unless you have square root of negative numbers, but somehow if you manipulate them with imaginary numbers, you will still end up with real roots. Like magically it works out. So that's the historical way of introducing complex numbers, and you could work through that and then explain everything else. Mm-hmm. But it's not the most natural way to think of a complex number. Like I think the most natural way to do it is actually to parachute it and just say like first we have the complex numbers, then we're going to look at the real line within the complex numbers. There's like a much more concise, much more neat hierarchy in mathematics, which doesn't match at all with historical purpose. And the question is like, in which order you teach first? Do you teach from like the hindsight of having seen the whole structure and knowing the whole structure, like this is the clearest path, or do you teach the tortuous path by which you get to those constructions?
Right. Certainly, I think that lots of electrical engineering students learn these, let's say, imaginary number informed tools or formula, and some just just do it because it works, but then some percentage just gets hung up on, yes, but what is it? What is this? I don't understand why this is here.
Yeah, and what it is, and we're going back to what I was saying earlier. It's a technique. It's the same thing with like people who the ultra infinitists, like people who say like no, infinity doesn't make sense. We can't do math. If there's infinity, it doesn't mean anything. But the point is like all the statements you're going to make about the world are going to be finite. You're making finite statements about finite collections of things. It's just that if you embed yourself into a formal world in which you have infinities, then you're going to have a much easier time. And then you cast it back down to a world that's very tangible. And as long as you trust your casting and downcasting, you're going to be fine. It doesn't have to be anything ontologically real or not about the world, in which you're embedding things.
Right, right, right. Well, I think that another edge that we're on is the edge of human understanding of emergent phenomena. The Santa Fe Institute is not very old. This exploration of emergent phenomena as a formal discipline is still very young, and now we've got one in the form of AI that does things that we can't understand precisely because we're just, as a species, still learning what techniques to bring to bear to understand emergent phenomena at all. So then this one's really surprisingly powerful, and that's scary.
Yeah, one of the things that I thought was the most interesting was, and this is like a film a few years ago. This was at a time where all the image models were really, really bad at letters, and they're still not great, right? They're still not great, right? But they got better. But then Google had this model called Imagine, and they had this image of a kangaroo holding a sign. And then they show the kangaroo like at a certain number of iterations, and all of a sudden, at some point, bam, it gets how to do languages and any language. It's kind of like gets it after a while. And then there's some papers contesting that. There's some papers saying like, no, like it looks like discontinuous jumps, but actually it's just like origins are wrong if you're following like another way to evaluate it is continuous. But it definitely feels like you somehow start unlocking some capabilities with scale that like deep crude capability that you didn't have it, at least on a anecdotal level. It definitely feels like that.
Well, it seems to me actually in all levels of human endeavor, whenever we encounter emergent phenomena, there's some complex explanation of this phenomenon that involves possibly multidimensional phase space and a bunch of, humble intellectual processes that are half-formed. Okay? Or there's always an alternative explanation that is a simple linear story with a beginning, middle, and end. We see this especially in politics, right? And the simple fact of the matter is, however smart we are, we're also all storytellers and story listeners, and simple linear stories are almost by definition better stories. So the reality of emergent phenomena is constantly being denied by someone that wants to sell you a linear story instead.
Yeah, and you see it a lot in math proofs, for example. Like there's a lot of problems which have which are fiendishly complicated and admit a simple proof. And you could get the proof explained to you, and you could easily convince yourself after you've heard it and that, well, of course, every step of the proof is very logical. You have a story where there's no question on what the next step should be, step after step after step, obviously. But I think I actually think that's helpful. Like if we can automatically, if we can brute force a lot of these things, and then clean it up, linearize it, and learn to produce those linear things. Because I don't think it's a complete magic trick. I think there's something real. I think it's true that with the right intuition, with the right frame of mind, we could have produced these linear stories. It's just that we don't. And training on these linear stories is if I had to grab an insight from all this is.
Oh, that's interesting. Okay, so when you can collapse something into a linear story, it is, of course, highly compressed. And therefore, if it has predictive power, it is the thing you should store in your brain, right? Like you want to store the compressed form of reality that has high predictive power.
But it's not just that. I think what I would describe as a short story is a story that it happens in a few steps, and you have a decent probability of making each step. And so the shorter the story is, the less likely you are to make a misstep. And what you need and what you need to learn is basically like putting the right weight on making the right step at the right time. But if you're sampling and you have random steps, it's like that's what it teaches you. And if you do that, then you'll reach the solution with higher probability in fewer steps,
Right.
as opposed to just like keep searching.
Yeah. Right. So yeah, when you find those, I guess it's time to terminate the learning process. You've got a good encoding.
Yeah, but it could be growing. Like you mentioned politics. I think in politics, probably this like, there's a version of it which is pure confabulation, which you just make up a story that actually has nothing to do with the causes. But there are cases where yes, there was a story. It's just that it's very we didn't get there. It's also like the famous like parallel reconstruction.
Right. Yes. Yeah.
We got to you because we were spying on everyone. We don't want to say that. But now that we know it's you, it's a lot easier to come up with an alternative chain explanation that points to you.
Right. Yeah. Yeah. I actually wonder how many stories of causality of all kinds that we hear about through the press or otherwise are actually precisely that, alternatively constructed linear narratives.
Entrepreneurial success stories, and this is what.
Yeah, beautiful example.
One is for those, there's selection bias, and I think also there's always like a retelling.
Yeah.
We want to have this inexorable sense, and again, it's like a little bit of animism. We want to have this inexorable sense of progress, and like everything happens for a reason. We get there,
right? Yeah. Well, Arthur, it's been a pleasure trying to take this basket of abstract concepts and turn it into a little bit of linear storytelling.
Yes. Thank you.
Thanks for coming on the show. How do people who heard about probabilistic programming, the applicability of stack traces to how learning works for humans and AIs, how should they find you?
Well, I can be found on Twitter at ARTHURB, Arthur. The blog post itself is on my blog, which I rarely update, but sometimes do. I get sit down and real write a brain up. X.rs, so it's EX Echo X-ray .rs, Romeo Sierra. I have to warn, the post is, I think it's probably one of my most interesting posts, at least to me. But it's also a bit of a brain dump, and it goes into a lot of things that might not be that relevant, which is like how particle filters work. Why particle filters can't really do program inference very well. Where does the problem lie? What does this imply about a bunch of other things? And then at the very end, I'm like, and so maybe all our intelligence is culturally transmitted through language.
Yeah, so we'll add those links to the show notes for anyone listening that wants to follow up. I found it absolutely fascinating. There's more material there than we could cover in even 1 hour, so we might have to delve into it further.
All right, thanks for having me.
It was a great pleasure. Thank you, Arthur.